Hello students, a warm welcome to MRS math class. Hope you are fine, staying at home and free from corona and enjoying my mathematics class. Today I am going to discuss about exact differential equation. Okay, what is a exact differential equation and how we can get the solution of a differential equation, and if it is not exact, then how we can convert it to a exact differential equation. Okay students, let us see the definition first. Definition of exact differential equation. Okay, so a differential equation m of x comma y dx plus n of x comma y dy equal to 0 is said to be exact if there exists a function u of x comma y such that d of u of x comma y is equal to m of x comma y dx plus n of x comma y dy. Okay students, so a differential equation m of x comma y dx plus n of x comma y dy, that means here there is the function m is a function of xy and n is another function of xy. We say this differential equation is said to be exact if we can find a function u which is a function of xy such that we can write it in this way. So let us verify this definition by taking an example. Okay, so consider a differential equation that is x dy plus y dx equal to 0. Okay, so this is in the form of this differential equation. We can write this one as d of xy, yes or no, by applying chain rule x dy plus y dx. So this one is an exact differential equation. If you take another simple example, that is your y dx minus x dy over y square equal to 0. This is another example. This one also we can write d of x over y, yes or no. So this differential equation 1 and 2 is an are exact differential equations. Okay, if you take another definition, that is x dy minus y dx, okay, equal to 0, then this one we cannot write in terms of d of u of xy. So this is not a exact differential equation. Okay, so now we will see sufficient and necessary condition. Okay, so write down a differential equation okay, m of x comma y dx plus n of x comma y dy is said to be exact if and only if del m by del y equal to del n by del x. Okay students, this is the necessary and sufficient condition for the exact differential equation. That means this is partial derivative of m with respect to y should be equal to partial derivative of n with respect to x. If this property is satisfying, then this differential equation is said to be exact. If it is exact, then it must satisfy this one. Now we will see the method of solution. Okay students, right, here we will do, that is m of x comma y dx. Here taking y as constant plus n of x comma y dy, the terms which do not contain x, okay, equal to c. So this way we can directly find the solution of the exact differential equation. Okay students, now we will take an example and we will solve using this method. So in this example what we will do, we will test that whether this differential equation is exact or not. If it is exact, then this by using this method we will get the solution for the differential equation. Okay, so the condition to check the differential equation is exact or not, we have to verify whether del m by del y is equal to del n by del x or not. Okay students, so this is our m of x comma y. So if we will take the partial derivative of this function with respect to y, then what we will get, del of y cos x plus sin y plus y with respect del y. Then what we will get, this will be our cos x, correct? Then this is sin y, partial derivative is cos y, correct? And this is 1. Okay students, now we will check del n by del x, that is del over sin x plus x cos y plus x over del x. So here sin x, the derivative of sin x is cos x, plus here cos y will be treated as constant, so x will be 1. So here del x by del x will be 1. So this one and this one are same, so we can say that this differential equation, let us say 1, is exact differential equation. So how we will get the solution? That is, first we will integrate this one, this function with respect to x by taking y as constant. Okay, so if we integrate this y cos x plus sin y plus y dx plus the terms which do not contain x, but here all the terms containing x, so here only we can take 0, that is dy, okay, equal to 0, equal to some constant c, correct? Then what we will get, we will get, if y is constant, then this is y cos x integration will be sin x plus here sin y into x plus here xy, right, equal to c. So directly we got the solution curve for the differential equation, this. Okay students, up to this we understood if a differential equation is exact, then how we can get the solution of it. Now we will understand if a differential equation is not exact, then how we will convert the differential equation to exact differential equation and we will get the solution of this. Okay, so while exactness coming to a matter, then integrating factor plays an important role. So let's just understand what is this. Okay, so let us consider the differential equation, that is your m of x comma y dx plus n of x comma y dy equal to 0. Okay, and if the consider that this is not exact. Okay, so write down the definition first. Okay, so an integrating factor, okay, let us say IF. Okay, an integrating factor is a function when multiplied by it, okay, the left hand side of equation 1 becomes exact. Okay students, so if we will multiply a function, suppose mu of x comma y to the left hand side of the equation, okay, m of x comma y dx plus mu of x comma y and n of x comma y dy equal to 0, then this left hand side we can write some function d of u of x comma y equal to 0. Okay students, so this mu of xy plays an important role here. So let us understand this by taking one example. Okay students, so if you will consider this example, you can check that this differential equation is not exact. Okay, so let us multiply this differential equation by x square plus y square. Then what you will get? That is x dx plus y dy by x square plus y square. Okay, plus and this one it will be x square dx equal to 0. Now you will integrate this equation, then what we will get? That is 1 by 2 log of x square plus y square plus x cube by 3 equal to some constant, can take 1 by 2 log c. Okay, since log is there, so we are taking this type of constant. Then your 1 by 2 log of x square plus y square minus 1 by 2 log c, it will be your minus x cube by 3. Okay, so if you will take 1 by 2 common, then you will multiply with that side, then we will get this log of x square plus y square over c equal to minus of 2 by 3 x cube. Okay, now if you will take this, then you will get your x square plus y square by c equal to e to the power minus 2 by 3 x cube, and finally x square plus y square equal to c into e to the power minus 2 by 3 x cube. So this will be the solution of the differential equation, or the non-exact differential equation, this, and we solve this one by multiplying x square, by dividing x square plus y square. So here integrating factor is x square plus y square, right? So to find this type of integrating factor, there are some rules. So one by one we will understand with an example. Okay. Okay students, now we will see the rule number 1 to find the integrating factor. Okay, so if mx plus ny is not equal to 0, okay, and equation 1 is homogeneous, okay, then 1 over mx plus ny will be the integrating factor for equation 1. Okay students, this is the first rule. If mx plus ny is not equal to 0 and the equation 1 is homogeneous, then 1 over mx plus ny will be the integrating factor for this equation. Okay students, so one remark you can note down here, that is, if mx plus ny is equal to 0, then what will happen? Then you will get m by n will be your minus y by x, correct? So from equation 1, m dx plus n dy equal to 0. So by dividing over n, this is m by n dx plus dy equal to 0, correct? So your m by n is y by x minus y by x. So minus y by x dx plus dy equal to 0, right? So your minus y dx plus x dy equal to 0, right? So dividing by y square, right? What you will get? That is and taking negative sign, that is y dx minus x dy over y square will be 0. So by dividing both sides y square, then this will be, this is an exact differential equation, that is d of x by y is this one, correct? So integrating this one, you will get x by y equal to c, correct? So your x will be c into y. This is one remark, and this is the solution for the differential equation 1. If mx plus ny will be equal to 0, okay? For not equal to 0, this will be the integrating factor, okay? So this one, rule number 1, we will verify by taking one example. Okay students? So now applying rule number 1, we will solve this differential equation. So you can see this is a function of degree 3 and this is also a homogeneous function of degree 3. Since both the functions are homogeneous of degree 3, so this differential equation is homogeneous, okay? And you can now we can check, that is mx plus ny whether it is 0 or not. So if you will compare this with this one, with equation 1, your mx will be this one, right? That is, and we will multiply with x. So it will be your x cube y minus 2x square y square, right? Plus n into y. This is your n into y, right? Plus 3x square y square minus x cube y, correct? So this is plus x cube y and minus xy, it is cancelled. So this is 3x square y square minus 2x square y square, that will be your x square y square, right? So this is not equal to 0. So as per the rule number 1, this mx plus ny is not equal to 0, and this is a homogeneous differential equation. So we can apply, that is our integrating factor will be 1 by mx plus ny, that is x square plus y square. Now we will multiply this one with equation number 2, you say, okay? So what you will get, if you will multiply with this, then here you will get x square, it will cancel, then 1 by y, right, minus 2 by x, right, dx plus this will be your 3 by y, right, minus this will be your x by y square, correct? x by y square, right? dy equal to 0. Okay students, now we will apply the same method, that is this one we will integrate with y as constant, and this one we will integrate where it involves only y terms, means without x terms. So here if you will see, then y is constant, so here you will get that is x by y, right? And here it will be minus of 2 log x, okay students, plus here this is 3 by y, this one only we will consider because this term is not involving any x term, okay? So your 3 log y equal to c, you can say, and this one will not consider because this term involves x, okay? So now we will come to here, okay? So that is x by y, okay, which implies x by y, that is be your here it will be log y cube log x square, right? Then this will be your plus log of y cube by x square, correct, equal to c, right? So your this will be our solution for the differential equation. This and this one we got by applying the rule number 1. Okay students, now we will see rule number 2 to find the integrating factor. Okay, if mx plus here minus we will take, okay, is not equal to 0, okay, and the equation number 1 has its form like your f1 of x comma y into y dx plus f2 of x comma y to x dy, okay, equal to 0, then integrating factor will be 1 over mx minus ny, okay? If mx minus ny is not equal to 0, and equation 1 will be of the form some function of xy into y dx and some other function xy into x dy equal to 0, then integrating factor will be this one, 1 over mx minus ny, okay? Here also one remark is there, you can note down that here we have considered mx minus ny is not equal to 0, right? Then if mx minus ny it will be equal to 0, then what it will be in this case? You can see that m by n, right, will be here y by x, right? Now consider the equation number 1, that is m dx plus n dy equal to 0. By dividing by n, that is m by n dx plus dy equal to 0, right? What is the value of m by n? That is y by x, right? So y by x dx plus dy equal to 0, right? Now y dx plus x dy equal to 0, right? So come to here, you can write this as d of xy equal to 0. So integrating both the side, we will get xy equal to c. So this will be the solution for the differential equation 1 if mx minus ny will be equal to 0. But if it is not equal to 0, then integrating factor will be this one. So let us verify this rule number 2 with another example. Okay, so this is an example to verify rule number 2. That means using rule number 2 we have to solve this differential equation which is not exact. Okay, so here you can see that some function f1 of xy into y dx, some function f2 of xy, you can say this one, into x plus into x dy is equal to 0. So this is in the form of rule number 2. So we can apply the integrating factor, that is 1 over mx minus ny, right? So that is 1 over mx, right? So that will be your x cube, correct, and y cube, right, plus here x square, y square, right, plus xy, right, minus here it will be mx minus ny, right? Here we will multiply y. So this will be x cube, y cube, right? And this is minus, so it will be plus. That will be x square, y square, and this will be plus is there, so it will become minus. That is xy, right? So then we will solve this one, right? So x cube, y cube, it will cancel, right? Plus xy minus xy, it will cancel, right? Now the remaining term is x square, y square, right? Some mistake I did, I think, because here you will multiply x, right? So x square, y square is there. Here we will multiply y. So y square, x square is there, right? So x square, y square. So it will become 2x square, y square, right? So this will be the integrating factor for this equation. So we will multiply this integrating factor with our problem, right? So I can start from here. That is, after multiplying this one, what we will get? This will be x square y cube, then it is x square y square. So here you will get y, right, plus xy square, right, and y square it will cancel x, so you will get 1 by x, right, plus here it will be only y, so y it will cancel, that is 1 by x square y, right, 1 by x square y into dx, right, plus here if you will multiply this, then what you will get? This will be your x square y square is there, so it will cancel, only x will be there, right? X minus here it will be xy, only x it will cancel, so only minus 1 by y, right, plus this is x, so x it will cancel, so only 1 by x y square will be there, right, into dy equal to 0, right? So now what we will do? Now this became an exact differential equation, right? So after applying the same method, that is this one we will integrate by keeping y as constant, okay, and this term we will integrate where x term will not be there. That means only this one we will consider. So let us solve this one. So y as constant, so this will be here xy, correct, plus here 1 by x is there, so that will be your log x, correct. So here y is constant, that means 1 by xy, right, plus here this one will not consider, this one will not consider, only this term, that is minus of log y, correct, is equal to c. Okay students, now what we will do, that is xy plus minus 1 by xy plus log of x by y, correct, equal to c. So this is the solution for the differential equation, this. Okay students, now we will see rule number 3 to find the integrating factor. Okay, so if del m by del y minus del n by del x by your n is equal to f of x, okay, a function of x alone, okay, then e to the power integration of f of x dx is an integrating factor for equation 1. Okay, so if del m by del y minus del n by del x over n equal to some function which is of x alone, then integrating factor will be e to the power f of x dx. Okay students, so let us verify this rule number 3 by taking an example. Okay, so the example is x square plus y square dx minus 2xy dy equal to 0. So let us solve this one by using rule number 3. So here first we have to check that whether del m by del y minus del n by del x over n, what it comes. Okay, so this is m our in this case, right? So del m by del y if you will calculate, then this will be 0 and this will be our 2y, correct, minus del n by del x, that means partial derivative of this with respect to this one. So it will be minus 2y, right? So minus minus it will be plus, that means 2y, right, over n, that means minus 2xy, correct. So what you will get, 2y, that is 4y by minus 2xy. So it will come as minus 2 by x, so which is a function of x alone, right? So what will be the integrating factor in this case? That is e to the power f of x dx, that means e to the power your f of x is minus 2 by x dx. So what it will come if you will integrate, that will be e to the power minus 2 log x, correct. So it will be 1 by x square, right? Now we will multiply this integrating factor with this equation. So what we will get, that is, come to this side, that is x square plus y square, right, by x square dx minus 2xy over x square dy equal to 0. So you can see this was an exact differential equation, okay, and this will come as x square minus y square over x equal to 0. You can verify. So now we will integrate both the sides to get the solution. So what we will get, that is x square minus y square over x, it will come as c, right? Now x square minus y square will be cx. So this will be the solution for this differential equation, and we solve it by using rule number 3. Okay, now we will see the last rule, that is rule number 4. Okay, that is if del m by del y minus del n by del x over m equal to f of y a function of y alone, then e to the power minus of f of y dy will be an integrating factor for equation number 1. Okay students, if del m by del y minus del n by del x by m will be a function of f of y, that means a function of y alone, in that case our integrating factor will be this one. Okay, so let us verify this by taking one example. So this example will verify using rule number 4. Okay students, first of all we will calculate what is del m by del y, right? That will be your 4 means 12 x square y cube, correct, plus 2x, right? And your del n by del x, it will be 2 that is 6, right, x square y cube, right, minus 2x. Okay, now we will find out what is del m by del y minus del n by del x over m, that is 12 x square y cube plus 2x, right, minus 6x square y cube plus 2x over m, that is 3x square y fourth plus 2x y. Okay students, now you can see that here you can take common as 12x square y cube plus 4x minus 6x square y cube, right? So this one it will become 6x square y cube, right? 6x square y cube plus 4x over 3x square y fourth plus 2xy. Okay, now this one it will become as, you can take common as 2x, correct? So it will be 3x y cube plus 1, correct, over, if you will take common xy, then you will get as 3x y cube plus, here it will be 2, right? So since here 2x has common, so here it will be 2. Mistake I did. That is, so this one it will cancel. So 2x x it will cancel. So it will come as 2 by y. So this is a function of y alone, right? So this one will be so now we will calculate what is our integrating factor, right? That is your e to the power minus f of y dy, that is e to the power minus f of y is 2 by y dy, correct? So it will become e to the power minus 2 log y, right? That means it will be 1 by y square. So this will be the integrating factor for this problem. Now we will multiply 1 by y square here, right? What it will come, and that is once y square, if it will multiply, then it will become as 3x square y square, correct, plus 2x divided by y, correct, that is your dx, plus here if it will multiply y square, it will become as 2x y minus x square over y square dy equal to 0. So now this is an exact differential equation, correct? So this one we will solve now. So first this one will integrate by keeping y as constant, and this one will integrate where x term is not there. but here in each term x is there, so we can neglect this one. Only this one we will integrate by taking y as constant. So here you will get as y square x cube by 3, the 3 it will cancel, so y cube x cube plus 1 by y, 2x integration is x square by 2, so right. So what you will get x square by y equal to some c, correct. So your final answer will be y cube x cube plus x square equal to cy. So this is the solution curve for the differential equation this, and we solve it using the rule number 4. Okay, so students, very carefully you have to understand and you have to remember these 4 rules very carefully, and using these 4 rules we can convert the non-exact differential equation to exact differential equation, and we can get the solution by this way. Okay students, for your better improvement I'll give now some questions, and honestly you will try the questions. Okay, if any doubt you will face, then you can ask me in the comment box. Okay students, thank you.